This is section 1.8, part B, and we'll look at a couple more examples of solving quadratic inequalities. In our next one, we've got 2x minus 1 squared is less than 7. I'm going to follow the same technique as before. I'm going to start by saying, let's come up with solutions to a related equation. So I'm just going to say, what if this was actually 2x minus 1 squared equals 7? I would probably solve that using a square root method. If I simply take the square root on both sides right now, I would have 2x minus 1 is equal to plus or minus the square root of 7. 2x equals 1 plus or minus the square root of 7. And then just dividing by 2 to get x. Those are the two values that I'm going to want to put on my number line in order to form my test intervals. But if I'm going to know what numbers those really are, I'm probably going to need decimal approximations. So let's get those. I have 1 plus the square root of 7 divided by 2, and then 1 minus the square root of 7. Divided by 2. So approximately 1.823 and negative 0.823. All right, I'm going to put those on a number line to test my solutions. I've got negative 0.823 and positive 1.823. All right, I need to pick a test value in each of the three intervals that we've created. So for example, negative 1 would be a value that's less than negative 0.18 or negative 0.823. Between these two values, 0 would be a nice one. And then something bigger than 1.823, maybe just 2. I need to test those and see which of these makes the original inequality true. And again, my original inequality, what I'm testing for, is 2x squared minus, or 2 minus, boy, I can't talk today, 2x minus 1 squared is less than 7. All right. I'm going to use a calculator table just to make my job a little bit easier. I'm going to put this 2x minus 1 squared. And if I want to, I can put the 7 on the other side, or I can just remember it. That's kind of up to whatever you prefer. And then I'll go to the table. And let's just make sure my table is set up correctly. It is. I want to make sure my independent variable is set to ask, just like this. And in the table, the first thing I want to test is negative 1. You'll notice I got a 9 and a 7. I wanted that to be less than. It is not. So I'll be false in that interval. The next interval, the test value we chose was 0. That gives me a 1 and a 7. And again, I wanted less than. And that looks pretty good. 1 is less than 7. So in that interval, this is going to be true. And then finally, my last interval, I was going to test 2. So if I put 2 in, I get 9 and 7 again. 9 less than 7 is certainly false. And so the solution here, the only interval where this was true, was right here in the middle. So I'm going to write my solution is this interval right here. Now my original inequality was strictly less than, not less than or equal to, so I'll use parentheses. And depending on whether I want an exact value or an approximation, I can either write negative 0.823 to 1.823. Or if I want to be exact, I can go back to my exact values here and say this would go from 1 minus the square root of 7 over 2 to 1 plus the square root of 7 over 2. Oops, slide in there. All right, let's go ahead and take a look at the same inequality graphically. I'm going to flip over to Desmos. And I'm going to graph the left-hand side, 2x minus 1 squared. And then the right-hand side, just y equals 7. You can see those two intersection points, which were the same values that we got by hand, the negative 0.823 and the 1.823. And because we did want this square to be less than 7, we want the green parabola to be below the line. Notice that happens in between those 2 points, and therefore my solution did turn out to be in between these two x values. All right, let's try one more. Actually, I guess there's 2 more on this page. In this next one, we wanted 5x minus x squared to be less than or equal to 0. So once again, I'm going to start with my related equation. 5x minus x squared is equal to 0. Looks like I can factor out an x here, which would give me solutions at x equals 0 and also at x equals 5. We'll test those. And I do need, again, 3 test values, 1 in each section that my solutions split my inequality, my number line up into. So let's see. Let's go with maybe negative 2. I'm going to go with 4 and 6. Again, you can pick any values as long as they fit into the intervals. All right, I am testing to see if 5x minus x squared is really less than or equal to 0. So in my y equals, I'll put in the 5x minus x squared. And again, it's up to you. When it's just a constant over here, if you want to put the 0 in, you can. It's not absolutely necessary. And then I'll go to my table. My first test value is negative 2. I have negative 14 and 0. I wanted less than or equal to. And that's certainly true. My next test value is 4. I'm getting 4 and 0. Of course, 4 is not less than or equal to 0, so we're looking at false in that interval. And then finally 6. I'm getting negative 6 and 0. Negative 6 is less than or equal to 0, so we're true again. So the 2 places where this was true are the 2 ends of my number line. And in this case, it was less than or equal to. So unless I've got an infinity, I'm using square brackets. So from negative infinity to 0, square bracket on the 0, union or joined with the other part of the solution, from 5 to infinity. And again, notice that square bracket on the 5. If I were to check this one out using a graph, I've got 5x minus x squared. There's my parabola. I could put in y equals 0 if I wanted to, but notice I don't really need to because the x-intercepts are already identifiable without even doing that. So there's the 0 and the 5 that we found. And we wanted this to be less than or equal to 0. So this section of the graph is less than 0. That's from negative infinity to 0. And then this section of the graph is less than or equal to 0. That would be from 5 and then forever out towards infinity. So the graph definitely confirms what we found algebraically. All right, we've got one last example here to work on. I've got 4x squared minus 3x plus 5 is greater than or equal to 0. Starting once again with my related equation, 4x squared minus 3x plus 5 equals 0. Let's think this one through. If we were going to try to factor this, it's already equal to 0, so we could try. We'd need a sum of negative 3 and a product of 20. I don't think that's going to work. 1 in 20, 2 times 10, 4 times 5. No way to get that sum of negative 3. So I think I'm stuck with a quadratic formula again. The opposite of b is 3, plus or minus the square root of negative 3 squared minus 4 times the 4 times the 5 over 2 times 4. That's 9 minus 80. It's negative 71 under that radical. And it looks like I've only got imaginary solutions. Just like when we were looking at graphical solutions in the last section, on a number line, there are no places to put imaginary numbers. So when I go to do my test this time, there are no values to put on the number line. That means there's really only one interval. As I test, I'll pick any one test value anywhere in here, and the entire thing will either be true or false. So let's see. Let's pick 0, because it's such a nice, easy number. I can even do it by hand, right? If I were to plug 0 in here, I would have 0 minus 0 plus 5 is greater than or equal to 0, and 5 is greater than or equal to 0. So the whole thing is true. That means that my solution is going to be all real numbers from negative infinity to infinity. Of course, if that test had turned out false, then I would have had to have said no solutions to this particular inequality. All right, that brings us to the end of section 1.8.